Hello everybody, this is Dr. Seifbarghy. I'm presenting this paper with the title of Formulating Location and Allocation Problems for Smart Lockers in Last Mile Delivery with my colleague Dr. Kasap from American University of Kuwait. Okay, in this presentation, initially we have an introduction. As you know, we come across the rise of global e-commerce in the world, and day by day people are getting used to buy through electronic devices, and they do not go to traditional retail stores. For example, sometimes a retail store like IKEA was very interesting for people to go inside and buy, for example, something like furniture and other things. And as they did buying or they did the shopping, they also moved around and going, for example, to drink coffee and I don't know, different entertainments, okay? But this is not the case anymore, and it seems that people do not prefer the traditional retail stores, and they day by day they are getting used to use the e-commerce and buying through electronic devices. Now the problem is that when e-commerce is growing, the concept of last mile delivery also is finding higher importance. As you know, the last mile is the last step that we deliver a parcel to the customer, and the customer receives the parcel, for example, at the home or someone or somewhere, for example, like a collection point in stores or in shops and different places. That this is exactly what we are talking about today: smart parcel lockers. That physically we will show them in the next slides. And today the efficient management of last mile delivery is very important, because some reports say that they are 70% of the total logistical cost today. To reduce the high cost of last mile delivery, today smart parcel lockers or smart lockers have been introduced by transport operators in the industry, and usually they locate them in schools, subway stations, office buildings, service areas, such as, for example, gas stations, shopping centers, and railroad stations. In fact, in each place that there is a crowdedness, there is a congestion, and people come around each other, usually they locate the SPLs or smart parcel lockers. And smart parcel lockers allows consolidated shipments to clustered locations. And this by itself reduces the logistical costs, and on the other hand, it minimizes the environmental impacts of transportation. Smart lockers are, if you want to get a specific definition, we can say that they are smart and electronic boxes that are installed in specific places, and its main function is to receive, protect, store, and deliver any type of shipment. And smart locker is a good example of resource management and productivity, because instead of receiving the parcels to different customers in different places, we can consolidate them and deliver the products to the to the lockers and in a single place. If we want to say, or if we want to talk about what is the benefit of a smart parcel locker to customers as well as the transport operators, for customers it reduces their unnecessary waitings at home, for example to receive a parcel, and this is the main benefit for the customer. Of course, it will also reduce the cost of delivery for the customer, and from this societal perspective, it is very good solution for example, reducing the traffic congestion, noise, curbside, vehicular stoppage that are very that make terrible for people in today's traffics, and also they reduce the environmental pollution. This is a typical image or photo of the smart parcel locker. This is an example in an Iranian company whose name is Jabar company. It is one of the two famous companies that also design and use the smart parcel lockers for different companies. This company this company is a sub company of a bigger holding whose name is Fakhr company. Of course, the complete name is Fakhr Kala Novin Gostar Puya, and as you can see here, one of its sub companies is Jabar company, which began its activity in 2020, and we have gotten the idea of this presentation from this company. Jabar's main focus is on designing and developing smart lockers and providing technology-based services to simplify the process of sending and delivery parcel. And as you can see here, its customers are online stores for improving their delivery processes, courier companies, and other postal companies, and we can say that every logistical company can be a customer of this company. On parcel locker or smart parcel lockers location, different people have worked. For example, we have mentioned here some of the recent research. Elian 2021, they proposed a number of mathematical models for this purpose. Sweden and its colleagues in 2022 proposed the mixed integer linear programming for this purpose. Young and its colleagues proposed a bi-level programming. Bi-level programming is when we have more than one player in a game. And Ozyavas and colleagues in 2025, they considered a dual role for smart lockers. A point for picking up commodities by customers and point for transferring commodities. This is also very interesting paper. But in this paper, we have considered, we can say, three echelon supply chain, a central warehouse which sends the different pulses to some smart parcel lockers, and customers. We have two important decision variables here. Of course, in this model, that is the first model, we have assumed that all lockers have identical capacities. Yj and Xij are decision variables. Yj is for the location of the SPLs, and Xij is for the assignment. We have other parameters here like Fj, Bj, Di, and Cij for opening cost, transportation cost, demand of customer zones, and transportation cost between customer zone and SPLs. This is a very simple mathematical model for this. The Z is the objective function, minimizes total cost. The first constraint is for the capacity, and third and fourth constraints are the typical constraints in facility location model. We can extend this model to different capacities. When we have different capacities, we have to define the we have to extend the definition of Fj to Fjm, because m here is the index for different capacities. And as you can see, again, we have a total cost minimization cost. We have 4 constraints here. And these constraints also are typical in the facility location problems for capacity, allocation of all customers to at least or to exactly 1 SPLs, and etc. And the last model is model 3. It is a 2-level structure. As you can see here, in the 2-level we have a central warehouse, higher level SPLs and lower level SPLs, and finally customers. In fact, in this supply chain we have 4 echelons, but with 2 major levels for SPLs. In fact, the lower level SPLs are fed by the higher level. In this model, we have also defined some decision variables for higher level, like YJM, ZKM, XIJ, and for lower level, X prime and UKJ. That you can see the definitions here. All of them are binary variables. And in this model, we have also some parameters for opening costs of the higher level, lower level SPLs, and the other parameters are more or less like the previous models. This is also the mathematical model for this model. As you can see, sum of opening and transportation costs subject to some constraints for capacities and other typical constraints in facility location problems. Thank you very much. I'm ready for any questions. Bye.